Look around you. Science is everywhere, and so is technology. We have smartwatches that track our heartbeats, phones that fold in half, and medical sensors that stick to our skin like temporary tattoos. These amazing devices are getting smaller, thinner, and more flexible every day. But they all have one big, clunky problem holding them back: the battery. For decades, batteries have been these rigid little bricks. You can't exactly fold a brick, can you? This mismatch between our flexible gadgets and their stiff power sources is a major hurdle. It limits how we design our technology and what it can do. Imagine trying to wear a shirt with a small, hard box sewn into it. It just doesn't work very well, does it? This is where the need for a new kind of power becomes incredibly clear. Our current batteries, mostly lithium-ion, are fantastic for things like laptops and electric cars, but they are not built for the world of wearable and flexible electronics. They contain layers of solid materials and liquid chemicals, all packed into a hard metal case. If you try to bend one of these, you're going to have a bad time. At best, it stops working. At worst, it could leak, or even cause a fire. To truly unlock the potential of next-generation technology, from smart clothing to bendable screens, we need a battery that can move with it. We need a power source that is as dynamic and adaptable as the devices it's meant to power. The dream is to have electronics that feel like a natural part of our world. Think of a solar-powered jacket that charges your phone as you walk, or a health monitor woven directly into the fabric of a baby's onesie. These ideas aren't science fiction. They are the next logical step in our technological evolution. But to get there, we have to fundamentally rethink the battery. We need to move away from the solid, unyielding designs of the past and embrace something new. The challenge isn't just about making batteries smaller, it's about making them soft, stretchable, and safe enough to be worn against our skin or embedded into objects we use every single day. So, the mission is set. Scientists and engineers all over the world are on a quest to solve this power problem. They are working to create batteries that can bend, twist, and stretch without breaking or losing their charge. This isn't just a small improvement. It's a complete revolution in how we store and use energy. By cracking this code, we can pave the way for a future where technology isn't just something we carry, but something we wear. A future where our gadgets are seamless, integrated, and powered by batteries that are as flexible as our own bodies. It's an exciting time to be thinking about science and energy. So what makes a battery flexible? It's all about the ingredients and the recipe. A standard lithium-ion battery is like a layered sandwich with hard, flat ingredients. You have a solid anode, a solid cathode, and a separator in between, all soaked in a liquid electrolyte and sealed in a rigid case. If you bend this sandwich, the layers can crack, short-circuit, and fail. To make a battery flexible, we have to change every single part of that recipe. We need materials that can withstand being bent and stretched repeatedly. This means swapping out brittle components for ones that are inherently pliable and resilient, allowing the entire structure to move freely without falling apart. Scientists are exploring some truly amazing materials to achieve this. One of the superstars is graphene, which is a single layer of carbon atoms arranged in a honeycomb pattern. It's incredibly strong, lightweight, conductive, and, you guessed it, super flexible. Another amazing material is carbon nanotubes, which are like tiny rolled-up sheets of graphene. These materials can be used to create bendable electrodes that act as the battery's positive and negative terminals. Instead of a rigid separator, researchers are developing gel-like polymers that can stretch and move while still keeping the electrodes from touching. These gels are safer than the flammable liquid electrolytes in many traditional batteries. The design of the battery itself is also getting a major makeover. Forget the brick. Think more like a piece of paper or a thread of yarn. Some flexible batteries are built using a kirigami or origami approach, where strategic cuts and folds allow a normally rigid material to bend and stretch in predictable ways. Other designs involve printing the battery components as thin layers onto a flexible surface, creating a power source that is paper thin. There are even fiber-shaped batteries that can be woven directly into textiles, creating smart fabrics that can power sensors or lights without any bulky attachments. These new structures are key to making batteries that are not just bendable, but truly wearable. The difference this makes is enormous. A flexible battery doesn't just enable a device to bend, it changes the entire relationship between the device and its power source. The battery is no longer a separate, clunky component that needs to be hidden away. Instead, it can become part of the device's structure, Imagine a smartphone where the battery is integrated into its flexible screen, or a medical patch where the battery is part of the soft, stretchable adhesive. This integration allows for smaller, lighter, and more comfortable devices. It's a fundamental shift that moves us from carrying our tech to truly integrating it into our lives. Creating a battery that can bend is a fantastic scientific achievement, but it comes with its own set of very big challenges. One of the biggest hurdles is the trade-off between flexibility and power. Generally, the more energy you want to store, the more active material you need to pack into the battery. This usually makes it thicker and more rigid. Making a battery thin and flexible often means sacrificing its energy density, which is the amount of power it can hold in a given size. This means your bendable smartwatch might die after just a few hours. The goal is to find that perfect balance, a battery that is flexible enough to wear, but powerful enough to be useful for a full day. Safety is another huge concern, maybe the biggest one of all. When you are designing something to be worn against the skin, you have to be absolutely sure it's safe. Traditional batteries contain flammable liquids and can overheat if they are damaged. Now imagine that happening in a battery that is constantly being bent, stretched, and twisted. Scientists are working hard to replace these hazardous materials with safer alternatives, like solid-state electrolytes or non-flammable water-based gels. They also need to design the batteries so that even if they are punctured or cut, they won't cause a short circuit or start a fire. Making them intrinsically safe is a non-negotiable part of the design process. Then, there's the challenge of durability. A flexible battery in a medical sensor or a piece of smart clothing might need to withstand thousands of cycles of bending, stretching, and even being put through the washing machine. Each of these movements can cause tiny cracks or stresses in the battery materials, leading to a slow decline in performance over time. Researchers are testing new self-healing materials that can automatically repair these small damages, extending the battery's lifespan. They are also developing new encapsulation methods to protect the delicate internal components from moisture and oxygen, which can cause them to degrade. A flexible battery isn't very useful if it breaks after just a few uses. Finally, we have to talk about cost. Right now, the advanced materials and complex manufacturing processes needed to make high-performance flexible batteries are very expensive. Graphene, carbon nanotubes, and specialized polymers are not cheap to produce in large quantities. For these batteries to power the next tech revolution, they can't just be for high-end niche products. They need to be affordable enough for everyone. This is where innovation in manufacturing comes in. Scientists and engineers are developing new techniques, like roll-to-roll printing, similar to how newspapers are printed, to produce flexible batteries quickly and cheaply, bringing the cost down so they can become a part of our everyday lives. So, what does the future powered by flexible batteries look like? It's going to be amazing. We're moving toward a world of seamless integration, where our devices and their power sources are one and the same. Imagine transparent batteries built directly into the screen of your glasses, powering an augmented reality display that gives you directions as you walk. Or think about smart windows that can store solar energy during the day and then use that power to light up at night. These aren't just cool ideas, they are active areas of research. The future is not just flexible, it's transparent, intelligent, and completely integrated into the world around us. To make this future a reality, we need incredible teamwork. This isn't a problem one person or one group can solve alone. It requires collaboration between people from many different fields. We need materials scientists to discover and create new bendable and conductive materials. We need chemists to develop safer and more efficient electrolytes. We need engineers to design the innovative battery structures and the manufacturing processes to build them at scale. And we need industry partners to take these incredible lab discoveries and turn them into real-world products that people can buy and use. When science, engineering, and industry work together, we can change the world. The ultimate goal is to make energy storage invisible. We want to power our lives without ever having to think about plugging something in or carrying a bulky power bank. Power will simply be there, woven into our clothes, built into our homes, and even integrated into our bodies through biocompatible medical devices. Flexible, stretchable, and even biodegradable batteries will make technology feel less like a tool we use and more like a natural extension of ourselves. This will open up possibilities we can't even imagine yet, in fields from healthcare and communication to fashion and entertainment. It's a future powered by ingenuity. It all starts with that one simple idea, a battery that can bend. From that single concept, a whole new technological ecosystem can grow. It's a powerful reminder that sometimes, the biggest revolutions begin with the smallest, most flexible ideas. The road ahead has its challenges for sure, but the progress we're seeing is incredibly inspiring. By continuing to push the boundaries of science and engineering, we can and we will build this flexible, powered-up future. So let's get to work, because the future is waiting, and it needs a charge.